Hello everybody. Apologies for taking so long to make this video, but here it is. We'll be replacing the joystick on an Xbox One Elite Series 2 controller. If you're having troubles with your joystick and it needs replacing, look no further because this is the video for you. As always, I will have a link to the kit used in the description below. And by purchasing it, it directly supports the channel and is greatly appreciated. In it, you'll find a really useful prying tool, as well as some high-range potentiometers that not only can make this install a lot easier, in some cases they may even be necessary. That's because these controllers have little room for error in respect to range. But don't worry, I will cover how to deal with that problem should it arise as thoroughly as possible. And the best part about this repair, as I'm sure a lot of you are going to be pleased to hear, is that there is no manual calibration required. You heard me right. No need for chopping pots, bending pins, or twisting them to get them calibrated. This is because the Elite Series 2 controller has integrated software that allows it to automatically and continuously calibrate itself. Truly remarkable and revolutionary. It's just too bad this feature isn't available on all of their controllers, but what can we do? Without further ado, let's get on with the repair. In the kit, as mentioned earlier, you'll find the double-sided metal prying tool. I've tried multiple tools for the job and found this one to be the best. We'll be using it to pry the faceplate off, and the best place to start is at the top of the controller. There are 13 clips and 2 pieces of double-sided tape that hold the faceplate on. By prying upward next to each of the clips, it should make easy work of removing it. Be a little careful as it is possible to break some of the clips if prying too forcefully. After we get that removed, there will be 6 T8 security torque screws to remove. One of them is hidden under the white sticker. Next, we will be removing the metal dome pieces. They are screwed on, so to remove these, grab a thumbstick and twist counterclockwise. The taller one is easiest to work with. They can be quite difficult to remove because there is some thread lock or something similar in them, but with enough force, they should come undone. I do caution to be a bit careful at this step because I have had some people tell me that they ended up breaking their joystick, which can make it even more difficult to remove. The best advice I can give is try to keep the dome piece as perpendicular to the controller as possible while twisting. If you find it secured pretty well like I did here, you may decide to use pliers like I did. Alternatively, you can also try heating up the dome pieces, which may loosen the adhesive material inside and make it easier to remove. Just be sure to not melt any of the surrounding plastic if you decide to try that. So, once we have those removed, it's time to remove the backplate. I like to pry up near each rumble pack. And to remove the motherboard and rumble packs, there will be 2 small cables, 2 T6 torque screws, and 8 rumble pack wires that will need to be removed. Because they used lead-free solder on these controllers, it requires a higher temperature to heat it up. I use around 700 to 750 degrees Fahrenheit. In addition, we can also add some of our own 60-40 solder to aid in melting it. Afterward, the way to remove the motherboard is lifting it up over the left post first, then give it a slight turn and twist to lift over the right post. And don't forget the headphone jack. Now we'll be placing the motherboard onto a helping hands. Because this board has small through holes, not to mention the lead-free solder, I highly recommend using the disassembly method if all you have to use is a soldering iron. If you have a desoldering iron or a heat gun, you can certainly just use either of those to remove the joystick in one piece. As for the disassembly method, the idea is to chop the joystick up into pieces to remove each pin one by one. To start, you will first want to pry open the potentiometers. If you don't have any stick drift, you have the option to try to leave these in, which I will demonstrate with the first example. Alternatively, if you only have stick drift, you may just want to replace the potentiometer that is causing the drift. I have a separate video specifically showing how to fix stick drift, even though in this video, I will be showing how to remove and replace the potentiometers a little later on. On to disassembling. Once the potentiometers are out of the way, you can then cut each of the four corners. And with a little bit of probing and prodding, you should then be able to remove the central part of the joystick. Then you'll want to cut the top and bottom frame walls into two pieces. Following that is the button, which is supported by 4 pins. You'll want to cut as high as possible on each of these pins, which can be a little tricky to get to because the plastic base is a little bit in the way. But once one of the pins is cut, the other ones get easier. Separating the top frame wall will allow the plastic base to be removed. It's then best to straighten the pins for easier removal later. Because of the lead-free solder on these boards, I like to add my own 60/40 solder to the pins first. The solder I'm using has flux in it, so I didn't add any flux here, but adding flux to the pins first can help the desoldering process. Then it's just grabbing some tweezers or pliers to remove each pin one by one. I'd recommend not being too forceful when removing a piece because it could rip out one of the holes. If you do decide to remove the potentiometers, I highly recommend trying to remove them in one piece. I really like using a chisel tip for this because it can conveniently heat up all 3 pins at once. Just like with the other pieces, I like to add my own 60/40 solder, and when every bit of the solder is melted, gently pull on it to remove it. Alternatively, you can chop it into 3 pieces. I'm not the biggest fan of this though, because you can damage the board this way. In this example, it turns out okay, but you can see how it can scratch the board, which in some cases can cause damage. So I only recommend this option as a last resort. Finally, when all the pieces are removed, we can then remove the solder. Any standard solder sucker and wick should do the trick. After all the solder is removed, in this example, I'm going to replace the pots on the replacement joystick. Then place the joystick in and snap the existing pots into place. Sometimes you may need to straighten the pins to get the joystick to fit, and once it's in place, then solder the connections. Now we're going to test the joystick by connecting the motherboard to the front board, putting the dome piece on, then the cover. The reason we want to test it with the front cover on is because it allows us to see whether the joystick has full range or not. As mentioned before, the awesome thing about this controller is that it is self-calibrating. So I'm going to first let it calibrate itself by moving the joystick around. The motion I think works best is going around in half circles, then releasing and pausing. Then rinse and repeat until it centers itself. It only takes a minute or two this way, but if you know a faster way, please let me know in the comments below. After the calibration, it's time to see what the range is. In this case, it actually looks great. 100% in all directions. It's not a typical result, but I'll take it. The whole reason we want full range in the first place is because it will affect gameplay if it isn't. Basically, it hinders the ability to turn or move as fast as you'd like to. In my opinion, it's better to have more range than less range. If you're at this step and don't have 100% in all directions, don't worry, that's pretty normal, and there's a few things you can do. The first thing you can do is change an in-game setting called Max Input Dead Zone. Unfortunately, not all games have this at the moment. Most notably, the game Fortnite does not, while the game Warzone does. In the game Warzone, for example, you have the option to change it for the left stick or the right stick. Whatever range is on the controller is essentially what you would adjust it to. For example, if I'm getting 93%, I'll adjust it to 93, or perhaps even 92. Another way, without any physical adjustments, is in the Accessories app. If you go to the app and select the stick you want to adjust, you can select the Aggressive Curve adjustment. Doing this will adjust the way the joystick acts, so you may or may not like this. If either of those options don't work or appeal to you, there are two more physical ways to fix this. The first physical way is by changing to the high-range potentiometers. I did some in-game testing with these myself, and I actually prefer them on the left joystick because they offer a quicker response to movement. On the right joystick, however, I prefer the regular ones because they offer more precision, but I did find using the delayed curve with the high-range potentiometers in the Accessories app is a decent alternative. And now that brings us to our last method. This one is done by adjusting the potentiometer. I know I promised no pot adjusting because you don't technically have to do this, but in my opinion, this is the most concrete way to get max range with the original parts. Sometimes you'll have to end up using the in-game settings or the aggressive curve anyway, or simply decide not to deal with it, but I still think it's worth the try. In this example, I just changed the potentiometer to one that only goes about 93% to the left. It also goes 100% to the right, so it is a good candidate for this adjustment, and we might be able to get full range in both directions. If you find yourself with one that doesn't go 100% in either direction, then this method won't work on that potentiometer. For that scenario, if you have another pot to try, you can try your luck with a different one until you find one that does, or conclude that you'll have to use a different method on that joystick. To be able to adjust the pot, we'll first need to remove the 3 nubs on the corners of it. This allows it to change the position of it ever so slightly, and in most cases will get us enough adjustment that we need. To get the x-axis to go left, adjust the x-axis potentiometer clockwise. To get the x-axis to go right, adjust the x-axis potentiometer counterclockwise. To get the y-axis to go down, adjust the y-axis potentiometer clockwise. And to get the y-axis to go up, adjust the y-axis potentiometer counterclockwise. Because in this example, I want the x-axis to go left, I will be adjusting it clockwise. To do this, I'll get the solder melted, which will enable the pot to rotate freely, then turn it to the right simultaneously. When testing, it's very important to make sure it's recalibrated first, because if it's not calibrated while you're looking at the range, it won't be showing its true range. Luckily, in this case, I adjusted it pretty spot on, and I'm getting full range in both directions. Sometimes you may over-adjust it or under-adjust it, and you'll just need to try again. And that's pretty normal. Hopefully you get lucky too, but sometimes it may take several attempts. And that's it. Once the joystick is on and working to your satisfaction, it's time to put the controller back together. It's basically the same procedure as taking it apart, but backwards. First, make sure the cover is off and both dome pieces are off the joysticks. Then, put the headphone jack into place and screw in the 2 T6 Torx screws. Next, connect the 2 cables back into place. Sometimes this can be a little tricky. If you still have the 2 stickers, you can put them back on as well, although they kind of lose their adhesion a bit once taken off. Now it's time for the rumble packs. With the controller facing downwards like this, the small one goes on the left and the larger one on the right. For the cables, the bumper rumble wires go on the top 2 posts and the bottom rumble wires go on the bottom 2. And positive in this case is gray and red and go above their negative black cables. Then it's time to put the dome pieces back onto the joysticks. I like to put them on as tight as possible because if not, they may come loose during gameplay. Now we'll put the back part of the controller on. You'll want to depress the LT and RT buttons down a little bit while doing so. Next is screwing in the 6 T8 security torque screws. And finally, snapping in the front cover, then putting on the D-pad piece and thumbsticks. As always, one final test for good measure. And we did it! If you made it this far and successfully replaced the joystick, a big congratulations goes to you. Seriously, job well done. Thanks so much for watching this video. Comment and subscribe if you feel like it, and I hope you have a wonderful rest of your day. Take care.